Okay, so for this Spiral Kinematic 28, it talks about a car initially traveling 20 meters per second to the east and accelerating towards the west at 2 meters per second squared. So the car is traveling towards the east and is accelerating 2.0 meters per second squared, therefore making it -2, and the car is slowing down. And then a truck 60 meters west of the car is moving 16 meters per second towards the east, starts to move faster at 1.0 meters per second squared. And you can see here that it is getting faster. They both end at the same point because it is a one-lane road and both drivers are too busy fiddling with their CD players to notice each other. So you can see here, this is the origin, and the truck starts at the origin, and the car starts 60 meters west of the origin. So for my motion information, the first object was the truck, the second object was the car. Event 1 for the truck was the initial speed that the truck was traveling, and event 2 was when it collided with the car. The second object, like I said, was the car. Event 1 was the initial, and event 2 was when the truck collides with the car. The truck started at 0 seconds and 0 meters, and it was traveling at 16 meters per second, and its acceleration was increasing at 1.0 meters per second. Then for the car, it started at 0 seconds. It started 60 meters west of the car, so our initial position is 60 meters, and it was traveling at 20 meters per second. And the acceleration was decreasing at -2 meters per second. So for this one, what I did was I placed my equations for my final velocity and my final position, V2 and R2 for the truck, and final velocity and final position, V2 and R2 for the car. And then after finding my two remainder equations for both of the positions for the truck and the car, for the truck it was 16 T2 plus 1/2 T2 squared, and for the car it was 60 plus 20 T2 minus T2 squared. I went ahead and set both positions equal to each other because they both are going to end at the same position because they eventually collide together. So after setting them equal to each other, my equation became 1.5 T2 squared minus 4 T2 minus 60. Then what I did was I used the quadratic formula, because this is a quadratic equation, to go ahead and find the variable T2. For the quadratic formula, 4 plus or minus the square root of -4 squared minus 4 times 1.5 times -60, and that whole equation over 2 times 1.5. When I went ahead and factored out the equation, the only possible answer, because time cannot be negative, was 7.97. So therefore, T2 is 7.97 seconds. After I found my T2, I went back to my final velocity for the truck and added my T2 in my 7.97 into the T2, which gave me my velocity was 23.797 for the truck. I went ahead and did the same for my V2, which is my final velocity for my car, and that gave me 4.04 meters per second. Then I plugged in again the 7.97 into the position equations for both truck and car, and both of the answers came out to be 155.15 meters. So that makes sense. So therefore, they collide at 155.15 meters.